Namaskar, dear students, welcome. We are solving problems on differential equation from the book Differential Equations by Shepley L Ross. So far, we have done 10 problems from the chapter Exact Differential Equations, section 2.1. Today, I shall solve from that book. First of all, let us try to solve this problem. Question number 11, section 2.1, exercise Differential Equations by Shepley L Ross, your textbook. Now, suppose this differential equation is 1. Suppose this is 1. It is solved by initial value problem. This y1 equal to 2. y1 equal to 2. Compare this differential equation with, comparing one with m dx plus m dy equal to 0, we get. Comparing this with 1, we get mxy, here mxy equal to twice xy minus 3 and xy equal to x square plus 4y, x square plus 4y. Now, del m by del y will be equal to, it will be twice x. Here, del m by del x, this is equal to twice x. Here, take y as constant, therefore, this will be equal to 0, this will be. Therefore, does del m by del y equal to del m by del x? Del m by del x. Therefore, 1 is exact. Therefore, 1 is exact differential equation. 1 is exact differential equation. Now, since 1 is exact differential equation, this means there exists a function u of x and y. I am writing here u x and y such that m dx plus m dy equal to du. M dx plus m dy equal to du. This is equal to du. M dx plus m dy equal to du. Now, let me write here. Therefore, what is m? Means this, twice xy, twice xy minus 3 dx plus x square plus 4y dy equal to du. This means del u by del x dx plus del u by del y dy. Del u by del x dx, del u by del y dy. This means del u by del x equal to twice x. This is equal to twice x. Y minus 3. Suppose this is number 2. This is number 2. And del u by del y, this is equal to x square plus 4y. X square plus 4y number 3. 4y number 3. This is 2 and this is 3. Now, from 2, uxy equal to just partial differentiation of this with respect to x is equal to this. Therefore, it will be twice xy minus 3 dx, treating y as constant, plus phi y. You will get phi y. This is equal to, with respect to x, it will be x square y minus thrice x plus phi y. Uxy will be equal to this. Uxy will be equal to this. Suppose this is number 4. This is number 4. Uxy equal to this, number 4. Now, from 4 you will get, differentiate this partially with respect to y. This is equal to, it will be x square plus d phi y by dy. D phi y by dy. This is number 5. Now, see number 3 and number 5. 3 is del u by del y and 5 is also del u by del y. From 3 and 5 we get, x square plus d phi y by dy. This is equal to x square plus 4y. This means d phi by dy equal to 4y. This is equal to 4y. This means phi y will be equal to, it will be twice y square plus c naught. Now, what is phi y? Integration of 4y is, with respect to y, is twice y square. This. Now substitute this value of phi y in 4. Therefore 4 implies. What is this? X square y, not 4 implies uxy equal to x square y minus thrice x plus twice y square plus c naught. Now the solution of the differential equation is uxy equal to constant. Why? Since the differential equation is exact, therefore by the definition of exactness of a differential equation, m dx plus n dy should be equal to du. Now the differential equation is m dx plus n dy equal to 0. This is equal to du, means du equal to 0. Integrate this, u is equal to constant. Therefore the solution of one is uxy equal to constant. Therefore x square y minus thrice x plus twice y square plus c naught equal to constant, c1 equal to constant. This is equal to constant. Now c1 is equal to constant. Or you may write x square y minus thrice x plus twice y square equal to c1 minus c naught, or x square y minus thrice x plus twice y square equal to c. Twice y square equal to c. This is the solution of the given differential equations. But we are given that y1 equal to 2. Before applying the condition y1 equal to 2, we shall solve this problem in another 2 methods for your convenience. In examinations, you should answer and you should apply only one method, but I am giving you 3 different methods. In the first method, we shall we have solved, we have found that the solution is this. Now let us come to method 2. And here the same question, the method 2. Since since 1 is exact, this is 1. Since 1 is exact, its solution is, we have already proved that 1 is exact. Del m by del y equal to del m by del x. 1 is exact. Its solution is integral m dx, treating y as constant, plus integral m dy, taking only those terms which are free from x, which are free from x, that is which do not contain x. This is equal to constant. That is, the solution is integral twice xy minus 3, treating y as constant, plus take only those terms which are free from x. X square is here 4y. It will be integral 4y dy. This is equal to constant. Or you will get, after integrating, you will get x square y minus thrice x. It will be twice y square equal to c. In this method also we have got the same result. Now method 3. Let us come to method 3. Method 3 means method of grouping method. Now 1 can be written as 1 is twice xy minus 3 dx plus x square plus 4y dy equal to 0. Or group this like that: twice xy plus x square dy minus thrice x plus thrice dx plus 4y dy. This is equal to 0. This means y twice x dx plus x square dy minus d of thrice x plus d of twice y square. This is equal to 0. D of twice y square equal to 0. Or u, it is nothing but d of x square plus x square dy minus d thrice x plus d twice y square equal to 0. Or thus I am writing here in this side. From this means this can be written as d of x square y, minus d of thrice x plus d of twice y square equal to 0. D of x square y minus thrice x plus twice y square equal to 0. Twice y square, this is equal to 0. Integrating, just integrate it. Integrating x square y minus thrice x plus twice y square equal to c. 1, 5, this is number 6. This is number 6. You see, x square y minus thrice x plus twice y square. Here also x square y minus thrice x plus twice y square equal to c. Now apply the initial condition. Now apply the initial condition. Apply the initial condition. Given that y1 equal to 2, given that y1 equal to 2, that is y equal to 2 when x is equal to 1. When x is equal to 1. Therefore 6, from 6 you will get 1 square into 2 minus 3 into 1 plus 2 into 2 square equal to c. Or you will get 2 minus 3 plus 8 equal to c. This means c equal to 7. C equal to 7. Therefore 6 implies, from 6 you will get x square y minus thrice x plus twice y square equal to 7. This is the solution of the given differential equation. Question number 11. We have solved the question number 11. This is the solution. Question number 11. We have solved question number 11. Let us try to solve the question number 12. What is this? This is the question number 12. Solve the initial value problem. This initial value problem. Y minus 2 equal to 1. It is 1. Here, comparing this with m dx plus m dy, here m, which is also a function of m equal to 3x square y square minus y cube equal plus twice x and xy. And xy equal to twice x cube y minus thrice x y square plus 1. Del m by del y. You see, del m by del y will be equal to, treating x as constant, it will be 6 x square y minus thrice y square. Del n by del x with respect to x, 6x square y minus thrice y square. Same. Therefore, del m by del y equal to del n by del x. Therefore, 1 is exact. Therefore, 1 is exact. This means that there exists a function. This means that there exists a function u of x and y such that m dx plus m dy equal to du. M dx plus m dy equal to du. This means, what is m? Thrice x square y square minus y cube plus twice x dx plus twice x cube y minus thrice x y square plus 1 dy equal to du, means del u by del x dx plus del u by del y dy. Del u by del y dy. This means del u by del x equal to thrice x square y square minus y cube plus twice x. Suppose this is number 2. Del u by del y equal to twice x cube y minus thrice x y square plus 1. Thrice x y square plus 1. It is number 3. Suppose this is number 3. From 2, from 2, from 2, uxy equal to integral thrice x square y square minus y cube plus twice x. We are integrating with respect to x, treating y as constant, plus it will be pi y. This will be pi y. This means uxy, this is equal to, with respect to x, treating y as constant, y square constant. What is the integration of x square? The integration of x square is x cube by 3. It will be x cube y square. X cube y square minus, it will be x y cube plus x square plus pi y, plus pi y. Suppose this is number 4. This is number 4. From 4, differentiate it partially with respect to y. You will get twice x cube y minus thrice x y square plus d phi by dy. D phi by dy. This is number 5. This is number 5. Now, you see number 3 and number 5. In 3, del u by del y. Number 5, del u by del y. These two terms will be same. Therefore, from 3 and 5, left hand sides are equal, right hand side will be also equal. Twice x cube y minus thrice x y square plus d phi by dy, this is equal to twice x cube y minus thrice x y square plus 1. Plus 1. These two terms will be cancelled. This means d phi by dy equal to 1. Phi is a function of y only. This means phi equal to integrate this y plus c naught. It will be y plus c naught. Y plus c naught. Now substitute the value of, now substituting the value of phi in 4 we get. Therefore 4 implies uxy equal to x cube y square minus x y cube plus x square. Phi y means y plus c naught. Y plus c naught. Phi y means y plus c naught. Solution of 1 is y u equal to constant. Solution of 1 is uxy equal to constant. Equal to c1 say. This means uxy should be equal to x cube y square minus x y cube plus x square plus y plus c naught equal to c1. Plus c naught equal to c1. This means x cube y square minus xy cube plus x square plus y equal to c, where c equal to c1 minus c naught. This is the solution of the differential equations. X cube y square minus xy cube plus x square plus y equal to c. This is the. Now, before applying the conditions, we shall solve this problem by method 2 and method 3 also. Let us come to solve this equation by method 2. Since 1 is exact, each solution is integral m dx. M is minus y cube plus twice x, treating y as constant, plus integrate n dy, taking only those terms which are free from x, means which do not contain x. This contain x, 1 dy equal to constant. This means with respect to x, it will be x cube y square minus xy cube plus x square, and here from this y equal to c. In this method, we can solve this equation in this way. Method number 3, grouping method. Method 3. This is method 2. This is method 2. Now, method 3. Method of grouping. 1 is exact. Therefore, from 1 we will get thrice x square y square minus y cube plus twice x dx plus twice x cube y minus thrice x y square plus 1 dy. This is equal to 0. Plus 1 dy equal to 0. Now group. This means thrice x square y square dx. Now twice x cube y dy. Group this. Take this one and this one. Minus y cube dx plus let me see one thrice x y square. Thrice x y square. Yes, it is thrice x y square. Thrice x y square. Thrice x y square. Thrice x y square dy. Thrice x y square dy. This is minus, this is minus. Plus twice x dx plus twice x dx plus dy. This is equal to 0. Twice x dx plus dy. This is equal to 0. Now, from this y square, this can be written as d of x cube. You may write like this. Y square is there. Thrice x square dx means d of x cube. Plus x cube twice y dy can be written as d of y square. D of y square. This minus y cube dx plus x. It can be written as d of y cube. D of y cube plus dx square plus dy equal to 0. You may write like this. Now, this means from this first from d of x cube y square minus d of x y cube plus d of x square plus y. This is equal to 0. X square plus y, this is equal to 0. Or d of x cube y square minus xy cube plus x square plus y. This is equal to 0. Integrating we get Integrating, we get. If you integrate, you will get x cube y square minus x y cube plus x square plus y equal to c. Equal to c. Suppose this is number 6. Now, previously also x cube y square minus x y cube plus x square plus y equal to c. Now apply the given condition y minus 2 equal to 1 given there. Given there y minus 2 equal to 1. Therefore put x is equal to 1, no, x is equal to minus 2 whole cube 1 square minus 2 1 cube plus minus 2 square plus 1 equal to c. This is equal to c. Or this is minus 8 plus 2 plus 4 plus 1 equal to c. This means c equal to minus 1. C is equal to minus 1. C is equal to minus 1. Therefore, from 6 you will get. Therefore, from 6 you will get x cube y square minus x y cube plus x square plus y equal to minus 1. Or you may write x cube y square minus xy cube plus x square plus y plus 1 equal to 0. This is the solution of the given differential equation. This is the solution of the differential equation 12. We have solved so far two problems, 11 and 12. Let us come to solve the question number 13. Let us come to solve the question number 13. Question number 13. Here m equal to twice y sin x cos x plus y square sin x n xy equal to sin square x minus twice y cos x del m by del y equal to twice sin x cos x plus twice y sin x del n by del x twice sin x into cos x. What is the differentiation of cos x minus sin x? It will be plus twice y sin x. You see here both. Therefore del m by del y equal to del m by del x. Therefore del m by del y equal to del m by del x. Therefore 1 is exact. This is 1. Therefore 1 is exact. This means there exists a function u of xy such that m dx plus m dy equal to du. M dx plus m dy equal to d. Therefore twice y sin x cos x plus y square sin x dx plus sin square x plus minus, this is not plus, this is minus twice y cos x dy equal to del u by del x dx plus del u by del y dy. Del y dy. This means that del u by del x equal to twice y sin x into cos x plus y square sin x. This is number 2. And del u by del y equal to this one, sin square minus twice cos x. Therefore, this will be equal to cos x. Excuse me, equal to cos x. From this is number 3. From this is number 3. Number 3. From 2 you will get uxy equal to integral twice y sin x cos x plus y square sin x del x plus pi y. This means uxy equal to, with respect to x, partially treating y as constant, what will be this? Sin x cos x. What is the integration of sin x cos x? The integration of sin x cos x is sin square x divided by 2. Sin square x divided by 2. Twice 2 is there, therefore it will be sin square x. Y sin square x plus y square, it will be minus cos x plus pi y plus pi y. This means uxy equal to y sin square x minus y square cos x plus pi y. This is number 4. You see, this is number 4. Now, from 4, differentiate it partially with respect to y. You will get sin square x minus twice y cos x plus d pi by dy. You will get this one. Now, let me write here. From 3, suppose this is number 5. Left hand side of 3 is del u by del y. Right hand, left hand side of 5 is del u by del y. From 3 and 5, you see sin square x plus minus sin square x and minus twice y cos x plus d pi by dy. This is equal to sin square x minus twice y cos x. This means d pi by dy equal to 0. It will be 0. This means pi y will be equal to constant. Suppose this is C naught equal to C naught constant. Pi y equal to constant. Now substitute the value of pi y in 4. Therefore, 4 implies uxy equal to y sin square x minus y square cos x plus C naught. Now, solution of 1 is uxy equal to constant. C1 equal to constant. Therefore, you will get y sin square x minus y square cos x plus C naught equal to C1. This means y sin square x minus y square cos x equal to C, where C equal to C1 minus C naught. The solution of the differential equation is this. Solution of the differential equation is this. Now, we have solved this equation in one method. We shall solve this equation in by another method 2 and method 3. After that, we shall apply the given condition. Let us try to solve this equation by method 2. Method 2. This is 1. This is 1. 1 is exact. Method 2. 1 is exact. 1 is exact. Its solution is, therefore solution is, its solution is integral m dx treating y as constant. Integral m dx twice y sin x cos x plus y square sin x treating y as constant plus integrate m dy taking only those terms which are free from x, which do not contain x. It contains x, it also contains x. Therefore, it will be 0 dy equal to constant. This is equal to constant. If you integrate this, you will get y sin square x. It will be minus cos x. It will be y square cos x. This is equal to, this is 0, this is equal to constant C. Now you see here. In the previous way also, y sin square x minus y square cos x equal to C. Now, y sin square x minus y cos square x. Method 3, grouping method. Method of grouping. 1 implies twice y sin x cos x plus y square sin x dx plus sin square x minus twice y cos x dy equal to 0. dy equal to 0. This means y, just grouping method, just write twice y sin x cos x dx. Now write here plus sin square x dy, group this plus y square sin x dx minus twice y cos x dy equal to 0. This is equal to 0. Or y twice sin x cos x dx plus sin square x dy plus y square, it can be written as d of minus cos x plus minus cos x twice y dy. You may write like this and group this one. This means this can be written as d of sin square x plus sin square x dy plus, you may write y square d minus cos x plus minus cos x d of y square. This is equal to 0. This is equal to 0. Now, this means first function differentiation of the second function differentiation of the first function. Y sin square x plus, it will be d of y square into minus cos x. This is equal to 0. Or you may write d of y sin square x minus y square cos x This is equal to 0. Integrating y sine square x minus y square cos x equal to c. This is equal to c. Suppose this is number 6. In the method 2 also, in by method 1 also, y sine square x minus y square cos x equal to c, and y sine square x minus y square cos x equal to c. Now apply the given condition. The given condition is given that y0 equal to 3. Given that y0 equal to 3. Given that y0 equal to 3. y0 equal to 3. Therefore, 6 implies put x is equal to 0, y is equal to 3. 3 sine square 0 minus 3 square cos 0 equal to c. This means it is 0 minus 9 equal to c. This means c equal to minus 9. Therefore, put in 6 y sine square x minus y square cos x equal to minus 9, or you may write y square cos x minus y sine square x equal to 9. Y square cos x minus y sine square x equal to 9. We have solved question 11, 12 and 13 so far. Let us try to solve the question number 14. Let us try to solve the question number 14. Here y0 equal to 6. This is number 1. Here m equal to y e to the power x plus twice e to the power x plus y square. N equal to e to the power x plus twice xy del m by del y e to the power x plus twice y del m by del x equal to, it is e to the power x plus twice y. Therefore, del m by del y equal to del n by del x. Therefore, 1 is exact. This means that there exists a function. U of xy such that m dx plus m dy equal to du xy. Now, this means what is m? It is y e to the power x plus twice e to the power x plus y square dx plus e to the power x plus twice xy dy equal to du, which is a function. Du means del u by del x dx plus del u by del y dy. Del u by del x dx plus del u by del y dy. Now, this means del u by del x equal to y e to the power x plus twice e to the power x plus y square. It is number 2. This is number 2. And del u by del y equal to e to the power x plus twice xy. Suppose this is number 3. This is number 2 and this is number 3. Now, from 2, from 2 uxy equal to integrate y e to the power x twice e to the power x plus y square del u plus phi y. This means uxy equal to with respect it is x. With respect to x, it is x. With respect to x, y e to the power x plus twice e to the power x, it will be xy square plus d phi by dy. This is number 4. From 4 you will get del u by del y equal to e to the power x plus twice xy. Number one. It is phi y. With respect to y, it will be d phi by dy. This is number 5. We are integrating this, and it is as it is phi y. From 3 and 5. You will get e to the power x plus twice xy plus d phi y by dy. This is equal to e to the power x plus twice xy. This means d phi y by dy equal to 0. This means phi y equal to constant. C now. Phi y equal to C naught. Substitute this value of phi y in 4. Now substitute the value of phi y in 4. We get. Therefore 4 implies. Substitute the value of phi y uxy equal to y e to the power x plus twice e to the power x plus xy square plus c naught. We have got this one. Now, what is the solution of the differential equation? The solution of the differential equation is uxy equal to constant. The solution of one is uxy equal to constant. This is equal to constant. Uxy equal to constant. Therefore, uxy equal to y e to the power x plus 2 e to the power x plus xy square plus c naught equal to c1, or y e to the power x plus twice e to the power x plus xy square c1 minus c naught, or y e to the power x plus twice e to the power x plus xy square equal to c. This is equal to c. Yx square equal to c. We have solved this equation by method 1. Now, let us try to solve this equation by method 2. This is 1 by method 2. 1 is exact. We have already proved 1 is exact. Therefore, solution of 1 is integral m dx, treating y as constant, plus integrate n dy, taking only those terms which are free from x. No term is there, which there is no such terms. This is equal to constant. This is equal to constant. With respect to x, you will get this one plus xy square equal to c. Xy square equal to c. Previously also, this one y e to the power x twice e to the power x plus xy square equal to c. Y e to the power x twice e to the power x xy square equal to c. This is method 2. This is method 2. Now method 3. Method 3. In the examination, you should apply any one of this method. For your convenience, I have solved these differential equations by 3 methods. Method 3, grouping method, method of grouping. Method of grouping. Grouping. One implies, one is exact, one can be written as, what is 1? Y e to the power x twice e to the power x y square dx, y square dx plus e to the power x twice xy dy, twice xy dy. Now let me write here y e to the power x dx, group this with e to the power x dy, e to the power x dy, group this, plus twice e to the power x dx, only x is the, plus y square dx plus twice xy dy equal to 0. Group this one. Group this. Now from this you will get y d of e to the power x plus e to the power x dy plus d of twice e to the power x plus y square dx plus x dy square, you may write like this. This is equal to 0. This is equal to 0. Or d of e to the power x y plus d of twice e to the power x plus d of xy square equal to 0. Equal to 0. Let me write here. From this I am writing here. This means d of e to the power xy plus 2 times of e to the power x plus xy square equal to 0. Integrating we get. Integrating we get e to the power xy plus twice e to the power x plus xy square equal to c. This is equal to c. Please note. E to the power xy equal to this. Suppose this is number 6. Now we apply the given condition. The given condition was y0 equal to 6. Given that y0 equal to 6. Given that y0 equal to 6. Therefore, from 6 you will get e to the power 0 into 6 plus 2 times of e to the power 0 plus 0 into 6 square equal to c. Or this will be 6 plus 2 equal to c. This means c equal to 8. C equal to 8. Therefore, From 6 you will get. Therefore 6 implies e to the power xy plus twice e to the power x plus xy square equal to 8. This is the final solution of the differential equation. This is the final solution of the given differential equations. So far we have solved question number 11, 12, 13 and 14 of the book Differential Equations by Shepley L Ross. We have solved 4 problems today. Let us try to solve the question number. This is one. Let me check this one. This is the solution. This is the solution. Method 3. So have been applied here. Therefore, here mxy 3 minus y by x square equal to 3 minus x by y square. Del m by del y. Del m by del y. What is del m by del y? With respect to y, it is minus 1 by x square. It is minus 1 by x square. N equal to n xy. Y square minus twice x divided by xy square. This is equal to 1 by x minus 2 by y square. N xy can also be written as like this. Del n by del x equal to minus 1 by x square. This will be 0. This will be 0. Thus, del m by del y equal to del n by del x. Del m del x. Therefore, 1 is exact. Therefore, 1 is exact. This means that there exists a function u of xy such that m dx plus n dy equal to du. M dx plus n dy equal to du. This means that what is m? 3 minus y by x square dx plus y square minus twice x by xy square dy. This is equal to del u by del x dx plus del u by del y dy. Del u by del y dy. Del u by del y dy. This means that number 1 minute. Y minus 1 equal to 2. Y minus 1 equal to 2. The given condition is this. This means del u by del x equal to 3 minus y by x square. 3 minus y by x square. This is number 2. Del u by del y equal to y square minus twice x divided by xy square. Or you may write del u by del y equal to 1 by x minus 2 by y square. Suppose this is number 3. 2 by y square. This is number 3. Y square will be cancelled. 1 by x minus x will be cancelled. 2 divided by y square. From 2. Now from 2. From 2, del u by del x. This is equal to 3 minus y by x square. This means uxy equal to integrate 3 minus y divided by x square del x plus a function of y only phi y plus the function of y only phi y. This means uxy equal to, with respect to x, treat y as constant. Therefore, 3 minus y will be constant, will be treated as constant. 3 minus y constant. What is the integration of 1 by x square? Means x to the power minus 2, means x to the power minus 2 plus 1 by minus 2 plus 1, means x to the power minus 1 by minus 1 minus 1 by x. It will be minus 1 by x. 1 by x plus phi y or uxy equal to y minus 3 by x plus phi y. Y minus 3 by x plus phi y. This is number 4. Y minus 3 divided by x plus phi y. Number 4. From 4, del u by del y with respect to y, differentiate it, you will get 1 by x, only 1 by x, 1 by x plus d phi by d, plus d phi by dy, d phi by dy. This is number 5. This is number 5. The left hand side of 3 is del u by del y, and the left hand side of 5 is del u by del y. Therefore, right hand side will also be equal. From 3 and 5 we get. From 3 and 5 we get. From 3 and 5 we get 1 by x plus d phi by dy. This is equal to 1 by x minus 2 by y square. Minus 2 by y square. This means d phi by dy equal to minus 2 by y square. This means phi y equal to integrate minus 2 by y square dy plus the constant of integration c naught. The constant of integration c naught. This means phi y equal to minus 2. What is the integration of this? Minus 1 by y. Y to the power minus 1 divided by minus 1 means minus 1 by y plus c naught. Plus c naught. This means phi y equal to 2 by y plus c naught. 2 by y plus c naught. Now substitute this value of phi in 4. Therefore 4 implies. Substitute this value of phi in 4. 4 you will get uxy equal to y minus 3 by x plus 2 by y plus c naught. 2 by y plus c naught. The solution of 1 is uxy equal to constant. Uxy equal to constant. This means y minus 3 by x plus 2 by y plus c naught equal to c1. Notuba y minus 3 by x plus 2 by y equal to c, where c equal to c1 minus c naught equal to constant. This is equal to constant. Now, this can be written as y square minus thrice y plus twice x equal to cxy. This is equal to cxy. Y square minus thrice x plus twice y equal to cxy. we have solved the differential equations by method 1. Before applying the condition, let us try to solve this equation by method 2 and method 3. Method 2. This is 1. 1 is exact. 1 is exact. Solution is 1 is integral m dx plus take only those terms which are free from x, minus 2 by y square dy. Now since y square minus twice x divided by x y square equal to 1 by x minus 2 by y square, it can be written as this. This is equal to constant. This is equal to constant. Or with respect to x, you will get 3 minus y. It will be minus 1 by x minus 2 y to the power minus 1 by minus 1 equal to c. Or y minus 3 by x plus 2 by y equal to c. Or y square minus thrice y plus twice x equal to cxy. Y square minus thrice x plus twice x equal to cxy. This is equal to cxy. This is equal to cxy. Now we have solved this equation by method 2. This is method 2. This is method 2. We have solved this. Let us try to solve these equations by method 3. By method 3. Method 3. Method 3. Method 3. 1 implies, what is 1? 3 minus y by x square dx plus y square minus twice x by x y square dy equal to 0. Y square dy equal to 0. This means 3 by x square dx minus y by x square dx plus 1 by x dy minus 2 by y square dy equal to 0. You may write like this. Now 3 by x square dx minus or write 1 by x dy minus y by x square dx. Write like this. Minus 2 by y square dy equal to 0. 2 by y square dy equal to 0. This means you may write here d of minus 3 by x. D of minus 3 by x. Plus 1 by x dy plus y d of 1 by x. Group this one. Plus d of minus 2 is there. Y to the power minus 1 by minus 1 is there. Equal to 0. Now 1 minute. This means d of minus 3 by x plus, you may write here y by x, d of y by x plus d of 2 by y equal to 0. d of 2 by y equal to 0. Or d of minus 3 by x plus y by x plus 2 by y equal to 0. Integrating minus 3 by x plus y by x plus 2 by y equal to c. Or you may write here minus 3y plus y square plus twice x equal to cxy. This is equal to cxy. This is equal to cxy. This is number 6. Suppose this is number 6. Now apply the given condition. The given condition y minus 1 equal to 2. Given that y minus 1 equal to 2. Given that y minus 1 equal to 2. Y minus 1 equal to 2. Therefore, from 6 you will get minus 3 into 2 plus 2 square plus 2 into minus 1 c into minus 1 into 2. This means minus 6 plus 4 minus 2 equal to minus twice c. This is equal to minus twice c. Or minus 4 equal to minus twice c. This means c is equal to 2. C is equal to 2. Therefore, from 6 you will get 6. Therefore, 6 will get 6 implies minus thrice y plus y square plus twice x equal to twice xy. Twice xy. This is the final answer of the given differential equation. This is the final answer. Minus thrice y plus y square plus twice x equal to twice xy. Dear students, we have solved today in total 5 questions. Questions number 11, question number 12, question number 13, question number 14 and question number 15. All the problems have been solved by 3 methods. In examination, you should answer these questions by only one method. For your convenience, we have solved by 3 methods. Today, I want to stop here. Thanks for attending the class. Thank you very much. Dhanyawad. Thank you.